great. So in this part of the unit, we're kind of moving to like, okay, we know light is a wave. We can prove that it's a wave because it does diffraction and interference in the double slit experiment. Now we're moving on to like optics. So if light is a wave and it does these things, then what do we see? So one way that we see the world is called reflection. And reflection is when light hits an object, hits a new medium, and bounces back into the original. Your goal for this part of class is we're looking at the law of reflection, ray diagrams, specular and diffuse reflection, and we're probably not going to get to this classify images part, so we can just cross that off for now. I know we'll hit it later, so that's cool. So, law of reflection. Do you remember when we originally did the Slinky lab? When the wave went down the Slinky, it hit the barrier and it reflected back, but upside down. That is part of the law of reflection. The law of reflection says that whatever wave you have going in, we'll call that the incident ray. Well, that has to be at the same angle to the wave that leaves. We call that the reflected ray. But one thing to be careful about is like, where do we measure this angle from? So I'm going to turn the light off so it's easier for them to see this graphic. 2 seconds. In this demo, they're taking a laser light and they're rotating it around. It's got a little tiny mirror on the bottom here. And notice that the angle of incidence, so right now that angle of incidence is like going this way. Notice the angle of incidence and the angle of reflection are always equal. The rays are always symmetrical. I'm going to pause this so it's a little bit easier to see. The mathematical equation for this would be written like theta I. That's the, go ahead. The angle for this, or angle, the equation for this would be written as something like theta I is equal to theta R. So theta I, that's the angle of your incident ray. So see where the laser is? The incident ray to what's called the normal line. The normal line is going to be your first new vocab word. So if you imagine you take your incident ray, your mirror surface, this normal line is this perpendicular 90-degree angle. Now, that's because if you had a curved mirror, you had some sort of like rough surface, then you want to always be able to measure the angle from a reference frame that's stationary. So how to draw the normal line? You're going to take your mirror surface, wherever that is, and draw a 90-degree angle to that. I know, you can do it. If you're doing it on paper, what you can do is like grab a corner of a piece of paper to make sure that it's 90 degrees. I know that if you're doing it on the iPad, sometimes you can lock things in to make sure it's perpendicular. But your normal line should be perpendicular to the surface. So that way, when you measure your angle, your incident angle is 35. Your reflected angle is also about 35. And finally, your reflected ray bounces off the mirror surface at equal angles. It's symmetrical. Ta-da, that's it. Okay, but no, we'll go in more depth because that way you like see all the different ways you can do this. Let's take the image out of the background. The normal line is the line drawn perpendicular to your boundary. And when I want you to draw a ray diagram, I'm going to ask you to draw 5 things. It's a lot, but it's kind of like labeling transverse waves, right? I'm going to ask you to label 5 things. I'm going to ask you to label the incident ray, that's Ri. So Ri is the incident ray. The incident angle is theta I. The normal line is this dotted red perpendicular line. The reflected angle, that's theta R. And finally, the reflected ray. So if I were grading these, I probably wouldn't assign 6 points. I'd probably assign 1 point for both rays, 1 point for both angles, 1 point for the normal line, and a 4th point showing that it obeys the law of reflection. right? If I drew one and I can't tell that you mean those two things to be equal, then that might be a little unclear. So to show that two things are equal, you could probably you could put in those little geometry marks to show that those angles are equal to each other. So we call this the law of reflection. The angle that light goes into a mirror is equal to the angle that light goes out.